Good day, bright physics students. So in this video, we will be discussing the derivation of kinematics equation, but this time we'll not be using calculus in order to derive the remaining kinematic equations, but rather we will use algebra. Alright, so without further ado, let's proceed. So the first thing that we need to do is to find the essential equations. Alright, and this will be our base equations in order to derive the other three kinematics equations. So what are the three essential equations that we will need? So the first one will be the formula for velocity. And according to our previous lesson and previous videos, we defined velocity as the rate of change in position. So mathematically, this will be velocity is equal to delta x over delta t, where delta x is the change in position x, which then means that it's final position x minus initial position x, all over final time minus initial time. And that's our first kinematic equation. Alright, next, second most essential kinematic equation will be average velocity. Alright, so what if we encounter the problem that says that there is a single particle that has two different velocities and we wanted to arrive at a single velocity? So by then we need to get the mean of those two velocities, and in order to do that, and by doing so rather, we will obtain average velocity. So the formula for average velocity will be the sum of two velocities, so let's make it final velocity plus initial velocity all over 2. So it's just simply getting the mean or the average of two velocities. Alright? And the third one, the third most essential equation, will be the formula for acceleration. And again, we define the acceleration as the rate of the change in velocity. So if we try to write it down mathematically, we will obtain this one. So acceleration is equal to delta v over delta t, where delta v is the change in velocity, which then means that it's final velocity minus initial velocity divided by time. Okay, so now that we have the base equations, we can now proceed with deriving the other three kinematics equations. So let's start with kinematic equation number 4. So why do we need to derive the other three essential kinematic equations? Because it would then make our lives easier in solving different problems relating to uniformly accelerated motion. So what is the purpose of kinematic equation number 4? So what if we have encountered a problem that doesn't require us to solve acceleration? Alright, so we don't need to solve for acceleration, but we're given three different variables and then we're only looking for one. So what are those four variables? Again, we have three givens and one unknown in the problem. So what are these variables? So the first variable will be final velocity, second is the initial velocity, third would be time, and fourth will be displacement. So this then gives us all over 4 variables, right? So these are the 4 variables that could be or could not be present in the problem. So how do we do that, or how do we eliminate acceleration into our final kinematic equation? So we will use from equations number 1 and equation number 2. Okay, so we will eliminate acceleration in there. So what is equation number 1? Equation number 1 is the formula for velocity. So that's v is equal to delta x over delta t. And equation number 2 is a formula for average velocity. Average velocity, that's final velocity plus initial velocity all over 2. Alright, so the first thing that we need to do is to make equation number 1 linear. And to do that, we need to cross multiply delta t to the other side of the equation, which then gives us delta x is equal to velocity times delta t. Alright, so now we're left with equation number 2. As you may see, equation number 2 is equated to average velocity, and average velocity is still considered velocity. Alright, so we can substitute the value of average velocity inside our newly derived equation, which then gives us delta x is equal to final velocity plus initial velocity all over 2 times delta t. And now this is our fourth kinematic equation. Alright, so let's proceed with kinematic equation number 5. So just like what we did with equation number 4, we need to know first what is the importance of deriving another equation. So this time we don't really need, or we're not required to solve for final velocity. So we're not required to solve for final velocity, and in the problem it was described to find again 3 given and 1 unknown. So what are these? So acceleration is in here, initial velocity is also in here, time variable is also in here, and of course the displacement. Alright, so we need to eliminate final velocity into our formula for kinematic equation number 5, and to do that we need to use equations number 3 and equation number 4. Alright, so what is equation number 3? Equation number 3 is the formula for acceleration. Acceleration is equal to delta v, change in velocity, over change in time, where change in velocity is again final velocity minus initial velocity all over delta t. And equation number 4 is delta x is equal to final velocity plus initial velocity all over 2 times delta t. Alright, so what we need to do is to make equation number 3 linear and then equate that to final velocity, because that's our main goal, to eliminate final velocity into our final equation. So cross multiply delta t to the other side, so this will become acceleration times delta t is equal to final velocity minus initial velocity, and then transpose initial velocity to the other side of the equation, which then leaves us with final velocity is equal to initial velocity plus acceleration times delta t. Alright, so now that we have the value for final velocity, we can now substitute that into equation number 4. So let's do that. Delta x is equal to, so instead of writing final velocity there, we can write the value for final velocity in here. So initial velocity plus acceleration times delta t plus initial velocity all over 2 times delta t. Alright, so the numerator is simply the operators present in the numerator are addition, right? So we can just simply add both initial velocities, and this will give us delta x is equal to 2 initial velocities plus acceleration times delta t all over times delta t. And then we simplify. So if we try to simplify this one, all the terms inside the parentheses, this will then give us, so let me just write it in here. So this will give us delta x is equal to vi, so initial velocity, plus acceleration times delta t all over 2 times delta t. And then we distribute delta t inside the parentheses. So it will then give us this equation: delta x is equal to initial velocity times delta t plus acceleration times delta t squared all over 2. And now this is our fifth kinematic equation. Alright, so now we're down with the last kinematic equation. So as for the last kinematic equation, what we have here is that we don't really need, or we're not required to solve for time. Okay, we're not required to solve for time, and we have 3 givens and 1 unknown in the problem. And these are the 4 variables present and could not be present in the problem. So what are those? Initial velocity, final velocity, acceleration, and displacement. Alright, so how do we do this? So by using, again, equation number 4 and equation number 3. So from equations number 3 and equation number 4. So equation number 3 is again acceleration. So that's acceleration is equal to final velocity minus initial velocity all over delta t. While equation number 4 is delta x is equal to final velocity plus initial velocity all over 2 times delta t. Alright, now, again, our main goal is to eliminate the time variable. So to do that, let's use equation number 3 and equate this formula to delta t. So to do that, let's cross multiply delta t to the other side. So this will become a acceleration times delta t is equal to final velocity minus the initial velocity, and then divide both sides by acceleration. Okay, so we're now left with delta t is equal to final velocity minus initial velocity all over acceleration. And now we can substitute the value of delta t inside equation number 4. So this will then give us delta x is equal to final velocity plus initial velocity all over 2, and then substitute the value of delta t in here. So this will become final velocity minus initial velocity all over acceleration. Alright, so the denominator will be easy to solve. So this will become 2 times acceleration, and then it gives us the answer 2a, or 2 times acceleration. But on the numerator, you can see that these are binomials, and in order to multiply binomials, you may use the FOIL method. So FOIL method, that's front vf times vf, will then give us final velocity squared. Okay, so let's write it in here. So vf plus vi times vf minus vi. Alright, so by using FOIL method, we will arrive to this answer: final velocity squared outside minus vf vi inside plus vf vi, and then the last term, that's initial velocity squared, right? So initial velocity squared. Okay, but then as you can see, this is negative and this is positive, so this one's cancelled. So we're left with vf squared minus vi squared. So that's what will remain in the numerator part. So delta x is equal to final velocity squared minus initial velocity squared all over 2 times acceleration. And then we wanted to make our formula a little bit linear, so cross multiply 2a on the other side of the equation, so this will then give us 2 times acceleration times delta x is equal to final velocity squared minus initial velocity squared. And then transpose initial velocity to the other side of the equation, so this will then give us final velocity squared is equal to initial velocity squared plus 2 times acceleration times delta x. So this is now our sixth kinematic equation. Alright, to wrap it all up, these are the 6 kinematics equation for, again, uniformly accelerated motion, but then this is in one dimension. So equation number 1 is the formula for velocity. Equation number 2 is the average velocity formula. Equation number 3 is the formula for acceleration. Equation number 4, if we're not required to look for acceleration and all the other variables are present in the problem, this one's it. Equation number 5, if we're not required to look for final velocity and all the other variables are present. And equation number 6, if we're not required to find the time variable and all the other variables are present. So this will be the ones that we'll be using in order to solve problems in the next video lessons. So see you on the next video.